Welcome. In this video, we're going to see some of the useful capabilities of the TI-Nspire when we want to graph and analyze graphs, and we are targeting specifically AP calculus. So the first thing we'll do is to just enter a function that we can work with. So we will work with x cubed minus e to the x. So when the graph appears, it may happen that it's not a convenient window. What you can do here is go to menu and then choose zoom. So typically you're not going to slide over like I do, but you're going to press menu and then you're going to press number 4 and then you're going to press the number or letter that corresponds to what you want to do. One thing that some students like is to use zoom fit. It can be great and it can be a disaster. So in this example, if we choose zoom fit, it's really bad. As you can see from what we had before, this graph does not show the important elements at all anymore. And one key to notice that is that the y goes from 56 to negative 500. There's very little chance that this could be a window that we are actually interested in. So when you do something like that, know that you can always do Control Z and it goes back to where you were. So just like on a computer. So another option for zooms is zoom standard. This is the one, if you're lost, you should always go to. Just zoom standard, it brings you back to the standard video viewing window from negative 10 to 10. And well, the y-axis is just scaled as the x-axis. So since it's not a square, it doesn't go from negative 10 to 10, but it goes from negative 6 to positive 6. Here, we may want to click on the screen using this kind of clenching thing, and you can drag, and maybe you get what you have, what you want. And if you're still not happy, I think the most convenient one is just zoom out, you press where you want, and here's a graph that we feel we can work with. So, the first thing we want to just see is how to find a derivative. So derivative, you're going to go to menu. It's always going to be analyze graph, so it's number 6. And then you look at the list, 0, minimum, maximum, intersection, inflection, derivative, integral, and a few more. So derivative is number 6 again. Now you could find the derivative by kind of tracing the graph, but this is a terrible idea. What you want to do is simply go to the number you want to find the derivative for. So here, if we're interested in the derivative at x equals 2, you just press 2, enter, and there's the value of the derivative. You can drag these elements away if they are bothering you. One thing you may want to do is to copy this value and use it in the calculator. So what you do is you click on it once, and then you go to store. So store is control var. You have this image, these letter STO that stand for store. And then you select a constant, a letter that will be the actual storage value. So let's say just A. Enter, and now A is equal to 4.6109. If we go to the calculator, we press A, enter, we get the number. Notice how if I press B, it's just written like that, but if I press A, it's bold. When a letter is bold, it means it's actually containing a value. So back to the graph. If we now want to find an integral, same thing, menu, analyze graph, which is 6, integral, which is 7, and again, we're not going to trace and use the cursor to find the integral. We want to be precise, so we're looking for the integral, let's say between 0, it offers you here the comment lower bound, 0, enter, and it doesn't say upper bound here just because my second bound seems to be on the left of the first one, but if I move to the right, then you can see that it says upper bound. We actually don't care about that at all because we're going to click 3, enter, and automatically it tells us the integral right here. Once again, you could drag these points, which may be just fun to do, but it's never something you want to actually work with if you're solving an exercise. Now, if we're interested in finding the minimum or the maximum, again, menu 6, it's always the default. You can find the zeros of a graph, the minimum, the maximum. Let's look for the maximum. So it's number 3. This time, because we're looking for a point that is somewhere here, it doesn't really matter. You don't need to punch in value because it's easy to click and drag and go beyond. As long as your maximum is inside the interval that you've clicked and dragged, then it's perfect. Enter. So here's the max. The max is 10.216 and it is at x equals 3.733. So it's the same for the minimum, it's the same for the zeros, and if you happen to have two graphs, then you can do the same for intersection. If you only have two graphs, you just find the lower bound and the upper bound. If you have three graphs or more, which I don't really recommend, then the calculator will first ask you which two graphs are you looking for the intersection. So what we want to see now is the only one that's not in 6, it's trace. If you just graph trace, you can get the value of a function. Once again, let's find the value at -1. We're not going to try and find -1 here or drag this point. We're just going to type -1, enter, and the point is f of -1 equals -1.3679. All right, so we're going to remove some of these things. You can click on that and press delete. We click, delete, click, delete. All right. Now, if we ever have a piecewise function, what you can do when you go to tab and your function is you can add, just like in the calculator, you can add a vertical bar and then you give specific values for x. So for example, x is less than 2. So this limits your graph to values of x less than 2. And now if I have a second rule, I can go to f2 and maybe put x plus 0.5. And then I want this to be only for values of x that are greater or equal to 2. So here I can see basically a piecewise function. Now what you're not going to see is the whole and the full dot because really they don't exist. It's only something we do on paper to emphasize where the point is and where it isn't. So you're going to need to think about your graphs and where the value of x equals 2, where the value of x equal 2 is. Is it on the blue or on the red curve? When you have a lot of things on your screen, something that's very useful is to just click delete 3 times, delete, 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 and then it offers you, do you want to delete everything? You say yes, and you have a clean sheet. Okay, we're now going to talk about two things that are specific to AP Calculus BC. If we want to graph parametric or polar functions, we go to menu and it's number 3, and you select parametric, which is number 4. So for example, if we want x of t to be the square root of t plus 2, make sure you realize the independent variable is a t. And then y of t is, for example, sine of t. So here's the graph. It's a tiny little thing here. Notice how the t ranges from 0 to 6. So if we want to change that, if we want to go further than 6, you can just add maybe 26 and you'll have a longer graph. Similarly, what is the meaning of this 0.13 here? If you take another value, it'll calculate values less often. So here it's going to calculate the position of the point at t equals 0, at t equals 0.13, at t equals 0.26, t equals 0.39, etc. until t equals 26.28. So you can calculate values, points at increased for more steps or for less steps. Typically, you don't need to change that. Finally, for polar, it's exactly the same. Menu 3, polar coordinate is number 5, and you would get here, so whatever, trigonometry sine of 2, and in this case, the variable is theta. So where do you find the theta? It's here in the little pi. You go and you choose theta. Enter, enter, and here's the graph. Okay. So again, just for this polar coordinates, you can also change the range of theta and theta step. So in the end, I'll just press del, del, del again to clean up everything. And that's all we wanted to show. Thank you.